suppose secant of theta is equal to 4, okay? So again, secant of theta, just a little review, secant of theta by definition is the reciprocal of cos of theta. So if they tell us that secant of theta is 4, I could say that 4 has to equal 1 over cos of theta, and then I could use my mathematical skills to get cos of theta by itself. For example, I can multiply both sides by cos of theta, and then I could divide both sides by 4, and I would get cos of theta is 1/4. But we're going to use a shortcut for this. Can you see the shortcut and the easy way to switch between secant theta and cos theta? If secant theta is equal to 4 over 1, cos of theta being the reciprocal would be 1 over 4. And that's what we're going to mainly use. I just wanted to show you guys like the algebra that has to go into place if you wanted to do it and show all your work. Yes?
What is SEC?
SEC stands for secant. And we did this the class before, or did we? Did I introduce you secant? Yes.
Yes.
So
Yeah, it was one of
if
them.
you look at, I think it's on page 470,
You introduced us to the
right? That's when we got introduced to the reciprocal trig functions in the gray box of secant, cosecant, and cotangent. And you have to have those like memorized, which one goes with which. And of course, it's kind of bothersome that the one that starts with S doesn't go with sine, the one that starts with C doesn't go with cosine. The fact that it's cosecant should, in your head, like, oh, that fits nice with cosine. No, it's not. No. Just to mess with you.
Let's see.
I'm just thinking how bad it would be. Like, you hadn't heard of them before. I could have taught you them completely wrong and waited for 3 days and then said, just kidding. How bad would that be for your memory?
I'd make 10,000 errors on the exam. I'd somehow manage to get all 10 a year.
That would be very nice. True story though. Okay. Who cares if it's on the video? And I may have told you this story before, but my wife was on a trip to Europe, and they were on this bus trip with a bunch of other people, and she met this family that liked to do practical jokes. Like, usually you don't bring fake puke and poop along on trips, but this family would so that they could play tricks with people they'd never met before. They just loved practical jokes. And they said that when their kids were little, they found it terribly funny, but they decided to teach their kids the wrong animal noises.
Oh, this story.
So they would say, what does the dog say? Meow. Oh, good, good. And then they would show off their kids to other, hey, watch this. And they go through animal noises, and the kids would have all the wrong animal noises. And they thought it was terribly funny. And they turned out, they're okay. They're not ruined for life. But you have that dangerous power, right? You have that power as a parent. Teach your kids whatever.
What's
Reciprocal means when we take a fraction and we flip it, this is called the reciprocal.
Okay.
So with secant, because we take cos and we flip it to 1 over cos, that's why we call it a reciprocal function. Okay, so all of that was that cos of theta is 1/4. Determine the exact values of the other ones. If you know that cos of theta is 1/4, well, according to the cast rule, it could either be in quadrant 1 because cos is positive, and they're all in positive in quadrant 1, or in quadrant 4. But in part A, it says, we would like you to only look between 0 and 180 degrees, And if you're only looking from 0 to 180, it has to be in quadrant 1. So, I'm going to draw an angle in quadrant 1. We always go back to the nearest axis because, well, in this case, here's my angle. It happens to be perfectly the same as my reference angle. But in quadrant 2, I would need to make a triangle with my reference angle. In quadrant 3 with my reference angle, always back to the nearest x-axis. I label my angle, and since I know that cos of theta, cos is adjacent over hypotenuse, I can label that I know this is 4, or this is 1, and this is 4. And you're going to get really good at a squared plus b squared equals c squared. What number would be in the square root there? It's not 17 this time. 15. Good job. And once you have this triangle, well, which ones do we have to find out yet? We still need sine of theta. Well, sine of theta is opposite over hypotenuse. And if you know sine of theta, then cosecant of theta, its reciprocal, will be 4 over root 15. Tan of theta would be opposite over adjacent, and you wouldn't have to write that 1 there. But then cotangent of theta will be 1 over root 15. Now part B of this question says we actually want to find theta, and we're going to look from negative 360 degrees to 360 degrees. So that will include quadrant 1, but you see that it would also include quadrant 4. So I'm going to draw the angle in quadrant 1 like we had before, and I'm also going to draw the angle in quadrant 4. Again, both of these would go back. This would be a reference angle. This would be the same reference angle. This is 1, and this is 4, and this is root 15. On this triangle, this is 1, this is 4, and this is root 15. We'll talk a little bit about this domain that they've given us of theta, right? Is that how it's written exactly? Yes. So this domain means that we want all the answers from negative 360 degrees to 360 degrees. But when we talk about angles, we always talk about angles in standard position, which start on the positive x-axis, which start at 0. So even though my domain goes from negative 360 to 360, I'm going to think of this as, I'm going to color code things here. I'm going to think of it as positive angles. Well, the positive angles, that's easy. That would start at 0 degrees and go to 360 degrees. And in red, I'm going to think about negative angles. And negative angles also start at 0 degrees, but in this case, they would go to negative 360 degrees. Can you see that positive angles from 0 to 360 would be once around the circle in the positive direction? And if I went once around, that would include this angle there, and in the positive direction, this angle there. In the negative direction, that would include this angle here, and that angle there. So I find when I'm thinking about negative angles, I'm still going 0 to whatever angle I need to go up to. I'm just going in the negative direction. So in order to find all of these, you first need to find your reference angle. And your reference angle is easy to find. You're just going to use one of your triangles. And my reference angle, well, I know that cos was 1/4. So I'm going to need to go to my calculator and go cos inverse of 1 divided by 4. And I get 75.522. I'm going to read the question, what do we need to round to? We need to round to the nearest degree. So my reference angle is 76 degrees. In purple, are you okay that this one right here would be 76 degrees? In purple on the second one, if I know the green reference angle is 76, I could figure out the whole one by doing 360 degrees minus that 76 degrees. That will leave me with 284 degrees. Now our red negative angles. Can you see that this red angle is identical to our reference angle? But since it's red and it's negative, it will be negative 76 degrees. And this negative angle, and for solving negative angles, I first sort of think of distances or angles positive. This would still be all the way around 360, back 76, right? So it's going to be exactly the same, 284, but now we're going in the negative direction, going to be negative 284 degrees. So we found our reference angle, and now we can list all of the angles: 76 degrees, 284 degrees, negative 76 degrees, and negative 284 degrees. There's our final answer. Questions for practice on this one? 9, 10, and 11.
Can I have rulers for a sec?
Yes.